some kind of password changing service, and we want to dig a little bit deeper. So using some WMI enumeration through PowerShell in Empire again, we're going to enumerate all the services that are currently installed in the system that have the name pass somewhere within the name where they match that. Then we're going to pull out the name of the service and then the full binary path of where the binary is. So we see this password changing, or this password changer with this kind of a, whatever the exe path is, right? So we're going to go ahead and download this, and we're again going to take this off to like kind of an offline analyst machine. So pull it down, then we're going to fade out and go into our analyst machine. So we're going to skip. You would do kind of basic exe triage and figure out what it's written in, those types of things. We'll say we determined that it was written in .NET in this case, or C#, which is awesome for us because we don't actually have to reverse it. With .NET and CLR type applications and assemblies, you can throw them into a decompiler and you can go from the common intermediate language, like kind of runtime or the opcodes, and then go straight back to what the actual source code is. So our favorite tool for this is dnSpy. It's free and open source. We can just throw our binary in here and start tracing through. We see, I'll zoom in here in a second. We see kind of the entry points. Okay, the service is starting. We see this like create user function that looks like it's creating a help desk admin. All right, that's kind of weird. There's a generate, or this password function. Okay, this looks like it's some type of algorithm that's being used to set whatever the local admin password is. So we see there's a date, there's the host name, there's some kind of seed, and it looks like they're combining everything, MD5ing it, doing some kind of string transformation, and then like appending some kind of character at the end. So this is an algorithm similar to things we've seen in the field that the only secret information is the host name, essentially, and then whatever the date is. So this is nice for us because if we can enumerate the host name remotely from a machine, we can generate the local admin password and remotely compromise it. So because C# and PowerShell are so similar, it's really, really easy to take that algorithm and port it into PowerShell, which you see here. Now, from here, we're going to go one step further, and we are actually going to build a custom Empire module to execute this. So, right here you see it's the similar type of algorithm right there in this kind of custom Empire module. So I took just the basic template, put the PowerShell snippets in that basic function, and we're going to pair that with WMI, so invoke WMI method. So this will let us do remote lateral spread through WMI with the password being pre-generated and executed based on whatever the host name is. So we can just give it a host name, it'll go and essentially install an agent, which is I think pretty cool. Again, very similar to something we've actually done in the field. So now we need some targets. I know it's going to scroll off here in a second, but we're going to use a module, a PowerView module within Empire, and we're going to enumerate all the computers that have the Windows 7 operating system. So we're assuming this password changing binary is done for clients, and we just kind of, in the little network segment we're in, we're going to see what other machines they are. So we landed on Cirrus A, and we see, let's see, Kruger for Freddy Krueger and Jigsaw or some of the other hosts. So now I talked about path finding with Bloodhound. You can find a path from any node in the graph to any other node in the graph. So instead of just spraying agents to every single machine that we might have access to, we wanted to do like kind of targeted attack path execution. So we'll gather a lot of information, trace out exactly what we want to do, and then do targeted compromise on those sections. So we're going to see, is there a path from, I think like Jigsaw to the domain controller Vader? No, there's not. But there is for this Kruger machine. So we see it has a session, whatever. It's got a particular user logged in who's a member of Guild Calamitous Intent. But you see like this kind of nested group memberships that might have admin access to specific machines that have different users logged in. So with the information that we gathered in the first enumeration phase, we can actually start tracing out a multi-step attack path. Now, we're going to flip back. Cool. We're going to verify that the next step in this attack path is actually true. So we're going to use one of my favorite bits of functionality in PowerView, getting at local group. It's rolled into the get local group module in Empire. This will use the WinNT service provider or some API calls in the backend to enumerate the members of a local group on a remote machine. So I can figure out who's a member of administrators on a remote machine without having elevated access to that machine. So this really is kind of crazy to me that you're allowed to do this. Windows 10 Anniversary Edition, Windows 10 Anniversary Edition Server 2016 finally locked this down by default. So they're paying attention and realized maybe it's not the best idea to let any user in your domain know all the local admin memberships of every other machine in the domain. Because you'll see how this kind of comes into play and how we can build these attack graphs. So we verify, okay, this help desk admin is a local admin on this machine. So now we're going to start executing our attack path. We know we can use this algorithmic, like kind of WMI module to jump to the next Schroeder machine. So we're going to set it, execute it, and in the back end, it's going to task down some PowerShell to the pivot host. And then you see it generated whatever the seed and the password, and then it executed WMI with an Empire stager on the remote system and got it back. So this, when we did something kind of like this in the field, it only took less than a day or a few hours to go, about like less than one assessment day to go from pulling down a binary, pulling out the algorithm, building an Empire module, and then having essentially like, you know, an internal kind of O-day, whatever, not O-day, but whatever, an exploit on any workstation in the entire environment that made it really, really awesome. So the advantage of something like Empire in this situation is the ability to customize these things in the field and kind of roll with this new functionality. So okay, we compromise the help desk admin on this Kruger machine. We know that, I think who's the person that's logged in here? Okay, yeah. So we knew that the waif had a session here based on the Bloodhound data. So we could steal tokens, we can mimikatz, or we could just essentially migrate into their process. So we're going to PS inject into their process space and assume all their token privileges. So what's nice with Empire, it does a whole bunch of kind of black magic in the back end that one of my workmates worked up of taking ways to load up the .NET Common Language runtime into an unmanaged C or C++ process space that then loads up an assembly that then does a PowerShell runner and does a bunch of other stuff. So in result, what you guys should care about is you can run your PowerShell Empire agents in processes that are not PowerShell.exe. So we're going to migrate into her process space so we can assume her privileges. And then we're just going to use a regular WMI module for lateral spread to move to the next point. So we're going to move to the Voldemort server because we saw through that Bloodhound attack graph that the waif did have access to this based on her unrolled, like multi-nested group membership. So if you had just enumerated that server directly, you wouldn't have known, you know, does this person have access there, because these things can start to spider. And this, even though this is a relatively simple example, if you can think about these things at scale, if you're thinking about thousands of groups or thousands of users and systems, there is no way that you're going to be able, like by hand, to find every single attack path. You might get lucky and find one, but you're not going to find all of them. So, okay, so now from here, we know that the waif has access. Oh, wait, was it? Yeah. Okay, yeah, so Eric Hartman is a domain admin. Respect his authority.
This is the research and development group. They have their own domain because of this reason. They kind of do their own thing. So we have our production environment, another domain in the same force, so we're fine. Like, go ahead.
Yeah, we'll see. So, okay, now the last kind of lateral spread that I'm going to go over is something called subversive profiles. Has anyone heard of PowerShell profiles, or a few people? So, okay, whenever PowerShell.exe starts up, whether it's the ISE or regular PowerShell.exe, it looks through a series of locations, which I'll highlight here in a second, for your profile.ps1, which is a set of PowerShell code that's normally used for like shell customizations and things like that. Now, whenever PowerShell.exe starts, it's going to execute whatever code is in that profile. So there's a blog post, which I'll show in a second, where Matt Graber, my boss from the next room, talked about attackers potentially using this subversively for persistence. We're going to use it for lateral spread to get around script block logging. So essentially what's going to happen is we're going to generate the, zoom in a second, we're going to generate your Empire launcher code, and then using WMI and remote registry, we're going to push it over to a value on the remote system, execute a command that pulls it down and saves that malicious logic to a profile.ps1 in like the PowerShell program files, or the System32 Windows PowerShell profile v1 thing. Then we're going to execute PowerShell.exe on the host. It's going to start, load the profile, execute our actual logic. It's going to kill itself, and then we're going to restore what the original profile PS1 is. So all the client will see are, if you're doing command line logging or Carbon Black or anything like that, these really awesome solutions, you're just going to see PowerShell.exe starting. No command line flags, no command line whatever else. It's not doing -F for file or anything like that. Then if they did have an original profile, like the system will be completely cleaned up. So this module isn't public yet. We just need to clean up a couple of things, and we're going to release it in the next month or so. So this is the blog post that Matt put out, so investigating subversive PowerShell profiles. Highly recommend everybody reading it. It's pretty cool. So again, he kind of talked about this from a DFIR perspective of, you want to ensure that you pull all profile.ps1s when you're doing IR on a machine. For us, it doesn't really matter because we're using it for lateral spread, not persistence. And we repair and clean everything up. So there's, we're not really leaving any traces. So again, nothing super, super crazy, but we thought it kind of a cool new little lateral spread method. That, I don't know, command line logging has become more and more of a pain over the last year.
Okay, so because of the local admin password changing executable, you took advantage of the fact that the algorithm wasn't as secure as possible, etc., figured out what that password was on a different machine, and then leveraged that information to jump to one with the domain admin, and then use this PowerShell thingy to then run your code on our domain controller. Yeah, so you see up there, we're creating the profile, pushing it over, executing PowerShell.exe, we get an agent back, and we're repairing the profile. So okay, let's say we take care of that, then we're good, right? Oh yeah, I'm sure. All right, so that was attacking client to client. How many of you guys Kerberos on a regular basis? Anybody? All right, if you're not, you absolutely should be. So, Kerberosing. Kerberosing involves the abuse of user accounts that have SPN set. So SPNs, or service principal names, are configured for service accounts to kind of enable the authentication flow for Kerberos in normal Active Directory domains. So when a user requests a service ticket, a TGS, it sends, I keep forgetting exactly how, like this, Kerberos is extremely complicated, but when a user requests the TGS, it'll send the request for the exact spin with that user account to the domain controller, which will actually go through the Kerberos negotiation process, and the end result is you get a TGS that's sent back down to the user. With Kerberosing, you can request these tickets as a regular user, non-admin, and those tickets are going to be saved in your current process space. You can extract these because you own your current process space, extract them and transform them into such a way that you can then export them and crack them with Hashcat or John. So it's a way to, depending on how service accounts are configured, be able to brute force offline service account passwords. And service account passwords usually don't change very often, right? Like they're usually around for a long, long time. So previously, when you wanted to Kerberos, you would do a bunch of one-liners. And it's a Tim Medine a year and a half ago. I think he talked to Derby last year. Had kind of came up with a lot of this research, and then had all these one-liners request the tickets, and you could use Mimikatz to extract the tickets out of memory, either to disk or to like kind of base64 encode them in blobs. Now, thanks to a pull request by I think it's MachoSec from on the PowerView. The PowerView code in PowerSploit, there is a much, much easier way to do this without needing Mimikatz. So first, we're going to check what are our targets. We're going to use the get user module in Empire, which wraps get net user in PowerView, and there's a spin flag, which will return all users with non-null SPN set in the entire domain. So again, these are the targeted accounts that we may be able to Kerberos. So it's going to task everything in the back end, it's going to execute it.
And we should get the results back for, I think in this kind of sample, there's three. Let's see, we have the Ring, we have Death Star, and we have White Walker somewhere up there, I think. Yeah. Okay, so we have 3 different service accounts that we may be able to curb roast. Now we're going to go back to our Bloodhound analysis platform, and again, instead of just curb roasting everything and trying to exploit everything, we're going to do targeted compromise. So we're going to see, is there a path from any of these 3 service accounts to the domain admins group in Bloodhound? Like the first one, no. Let's see, Desert, no, it doesn't look like there's a path. But for White Walker, there is a path. So White Walker, which is a member of House Bolton and then member of the Guild of Calamitous Intent, which has access to that same Voldemort server that we used in the previous attack chain. So we know that if we cover the plain text credentials for the White Walker service account through nested group membership, we should be able to compromise that same server, migrate to Eric Hartman's process again, and then kind of go about the similar parts of the attack chain. So now let's curb roast. The Git spin tickets module. It's so nice. This is in Empire 2.0 that was released yesterday. So you can either, if you don't set any user account or request all tickets, if you, like in this particular case, we know we just want one with White Walker. And instead of doing all that stuff and running Mimikatz and doing multiple stages, it's just one file. It's going to execute it down. It's only like a dozen or so lines of PowerShell, and you can pull the encrypted component of the ticket out of memory. So, and it'll pre-format it, ready for cracking for John. So, like, way, way easier. It's just like one single step. You could run this essentially in, through whatever agent you want. You could run this through Meterpreter. You can run this through Cobalt Strike or whatever with the PS1 core. We're going to switch over to, I had the ticket saved off for John. We're going to go ahead and see if we can crack it. So again, just literally copied that text straight over, already kind of formatted for the cracking format for you guys. And we see White Walker's password is Jon Snow Sucks.
Okay, well, like I said,
Yeah.
these are the R&D folks. They love
Yeah,
Game of
yeah.
Thrones. I'm going to have some conversations with them.
So now we know the plain text credentials for the service account that lets us start to execute that attack path. So with the invoke WMI module in Empire, you don't have to use the current user's credential set. You can specify plain text credentials if you would like. So we're going to set the credentials for this White Walker service account. We are going to set the target to be that kind of Voldemort server that we are able to spread to with an additional hop from the client side with the password changing binary. Execute it. We get our agent back. We're going to do the similar, the same couple of steps that we did in the previous demo, to where we do our enumeration of what processes are running, because we know from the graph that a user has to be logged on or Cartman has to be logged on. So we're going to PS inject into this process. PS inject into this process again. It's going to do all that kind of crazy, .NET stuff loading up in the back end, which I think is like one of the coolest features of the project. We should get our new agent back here in a second. And now, instead of spreading an agent to a domain controller, in general, we want to probably try to stay off DCs as much as we can. We're going to be a bit stealthier and use DC sync. Has anyone used DC sync? Hopefully a good chunk of people, yeah. So DC sync was a module for Mimikatz written by Benjamin Delpy, Gentle Kiwi, and Vincent Letour. It allows you to simulate DC replication traffic. So the normal kind of traffic protocol that's used to replicate like password and like user information data between domain controllers, with Mimikatz you can now say on a client, inject Mimikatz, and I'll say, hey domain controller, I'm also a domain controller. Please give me this password, assuming you have domain admin rights. So we do have DA rights now, but this is a way to replicate the hash and historical password information for whatever account we want without running an agent or any type of actual code on the DC. So we are going to set the user account we're in the really.evil.corp domain, and we have the KRB TGT. That's going to execute this, and it'll inject Mimikatz down, do that DC sync functionality. And Empire also has a really nice credential store in the back end that can almost act as a golden ticket catalog. So it'll automatically scrape Mimikatz output and save all the information for you in the back end. So we see, let's see, Vader beta.relay.evil.corp is the domain controller. So saved everything out. And if you type creds, you see that everything is saved. It's going to save off the domain SID and everything else, and we'll show in the next part of the demo how easy it is after you DC sync or hash dump to use the credential store as a golden ticket catalog.
Okay, so, all right, a lot of stuff going on here. So you were able to get a service ticket for this Kerberos service account and basically take that ticket and crack it offline because of how Kerberos works. And then use that password, because it was a horrible password, cracked pretty easily, obviously, in order to gain access, to get domain admin access on this R&D domain. So when you do this Bloodhound stuff and pull the information from the environment, isn't that attack traffic?
No, so I mean, we do the enumeration once, and the collection component can either be as noisy or as quiet, kind of as we want, you know, per situation. And after that, all the querying is happening offline. So we're not doing additional LDAP queries every time. And the traffic itself is just LDAP enumeration for the most part for any type of the user group unrolling. And then it's a handful of like kind of typical API calls, remote net session to num type things like in the back end, that are going up against a couple of these servers. At this point, the only thing that I know of, there's probably some commercial products that can detect some of these components. The main one that I know of is Microsoft ATA for, I think is Adaptive or Advanced Threat Analytics. It can detect the remote session enumeration against a domain controller if it's installed, but it won't detect it against all these other servers. At this point, they don't detect kind of anomalous LDAP enumeration traffic. They say that that's coming, which kind of terrifies me, but we'll see, because there's so many devices, there's so many things that, you know, old network printers and address books and all this kind of crap that needs LDAP and plugs into LDAP. So there's a reason that people haven't, you know, locked down people running, you know, net group domain admins on domains, because lots of things plug into this functionality, and Active Directory is meant to be a directory for things to look up information. With Server 2016, there is the ability to, they've introduced ACLs that will let you lock down who can enumerate what information in the domain, which is also kind of scary. But that's not enabled by default, and we all know, I mean, we all know that all clients will enable and configure it perfectly as soon as it comes out, so I'm sure that'll happen. So now we saw, you know, we were in the really.evil.corp domain. We were in a child domain and a forest, so you guys have some kind of like forest trust relationship. So here we go. Okay. So we're going to go back to our initial pivot. So our unprivileged user of Ramsey Bolton on CRSA without any kind of privileges. And because we've DC synced, what we're going to do is kind of the SID trust hopping attack to elevate from the child domain all the way up to the parent domain. Normally, trust will flow down from the forest root down to everything else if you're enterprise admins, right? So about a year ago, this researcher named Sean Metcalf and Benjamin Delpy worked out a way to really weaponize an attack that's been theoretical for about 10 years, which if you have domains within a forest and you compromise any domain admin rights, or if you compromise a domain controller or the KRB, TGT, or whatever anywhere within the forest, if you can modify the SID history for a particular user and set the SID history to be enterprise admins, you can instantly compromise the root of the entire forest. So you can hop up. I know this blew my mind when I first kind of learned about it, and I didn't really believe it, but we've done it in the field and it works. So SID history is a migration function, or it's a function to facilitate migration between domains. So if you had like going from domain B to domain A, the idea would be when you take those users and migrate them in, you set the SID history to be the SID security identifier of their old groups. So this would preserve their access to the old groups. Again, the idea was meant for migration, but people realized 10 years ago that a theoretical attack was possible, to where if you could modify the SID history for your user to be enterprise admins, then you became an enterprise admin within the forest. But in order to do this previously, you had to like hard modify stuff in the ntds.dit. It's a super, super, super protected attribute. It's a giant pain in the ass to modify. But with the golden ticket component that it figured out, you can set the SID history in the golden ticket, inject it, and then just instantly hop up. So it was finally fully weaponized. So the one bit of information we need, last bit of information we need, is the SID of the root domain. So we know the SID of our child domain, but we want the SID of evil.corp. An easy way to do this is with this user to SID functionality from Power View or Empire. Just take that username and it'll translate it to the full security identifier. So we know KRB TGT always has to be there, so that's the one I tend to use. I'm going to copy off the domain SID. We need that to create, that SID-519 is the SID for enterprise admins for the forest. Now we're going to create a golden ticket. I mentioned the cred store. So what's really nice is if any Empire modules have cred ID, it'll accept just a number of the cred store that'll automatically auto-populate and fill in the KRB TGT hash, the domain, the domain's original SID, and all those kind of components. So you can, again, use it kind of like a golden ticket catalog. And I'll scroll up the screen, but I'll do an info to kind of show you all the stuff. But we're setting the SIDs, so the extra SIDs, to be the forest root SID-519 for enterprise admins. And also, does anyone know about the 20-minute rule with golden tickets? A little bit. It's a little more unfamiliar for people. If you create a golden ticket, you have 20 minutes to run around with it before the domain controller verifies that that account exists or not. So that's the only validation that they do. They don't verify, like, is this user in the right groups or whatever. They verify if the account exists. So if you create a golden ticket for a user that does not exist in the domain, you have 20 minutes to run around and then really have fun with event logs with defenders. So I've known people that may or may not have cross-site scripted Defender SIM solutions by stuffing JavaScript into user account names, but that's another story. So root SID-519, right? As soon as we inject this, we should essentially become an enterprise admin instantly. And again, showing that just kind of that trust graph. This is a simple one. If you have a really complex environment, it becomes a little easier to navigate in Bloodhound. So we're going to execute it, and it'll also do pass the ticket, so it won't save anything out to disk. It'll inject the ticket straight into memory, which we can purge later if we need to. Come on. All right. And this, in the back end, this is all using Invoke Mimikatz, which was based off of work by Joe Bialik at Microsoft. So he was one of the guys that really introduced a lot of awesome functionality into the PowerSploit project. So we see here, we have that user that doesn't exist, to have fun with the blue team, and then we have the extra SIDs to be the forest root SID-519 for enterprise admins. So now the last part we're going to do is we're just going to go ahead and DC sync the forest root. I know, I don't know if you've had the advice to change your KRB TGT account.
Yes, actually, we rotate that automatically every couple of hours.
Okay, do you just do that?
They told me that would fix golden tickets.
Do you just do that in the forest root?
Yes, of course. That's for a production environment.
Yeah. So the really fun thing with the SID hopping kind of attack is, in order to ensure that you're not compromised forever, you would have to rotate the KRB TGT account on every domain in your entire forest all at the same time. Because essentially, any KRB TGT account and any child domain controller in the forest can be used to compromise the forest root and anything else. So, in the SID hopping attack, it doesn't matter if the KRB TGT rotates. We just got it, and within a minute, we could, hop up and DC sync. But yeah, you have to rotate it for every single domain in your entire forest at the same time, repeatedly on a regular basis, if you want to ensure that you're not going to be completely compromised. Because if they compromise a child domain, and then you rotate a few other things, and they forgot one of the children domains, then you can just hop back in, get your EA access again, and go to town. Okay, so from my R&D domain in my Active Directory forest, you compromise that to then jump to my production environment and now have full domain admin rights in my domain, in my forest. Yep.
Okay, well, that's pretty awful. So the thing I don't get is, I spend millions of dollars every year on security tools. I mean, I have vendors coming in all the time, and they say that they have the best security, and I showed you. I mean, I've got security tools, and I mean, web content filtering didn't matter, email didn't matter, none of these things seem to matter, and like we detect Mimikatz, like we have antivirus, but you said you use PowerShell for that, so it seems like you're a very smart guy, and I've got great security people. What am I supposed to do?
I mean, obviously come like these fine people, come to conferences, come to things like DerbyCon, you know, go have conversations with people in Hallway Con, you know, go to trainings. There's a lot of, you know, really good kind of AD type stuff out there. So people have started to pay more attention to Active Directory exploitation in the last couple of years. So we're happy about this, and there's a lot of information out there for people to learn from.
Okay, so it sounds like maybe I need to invest more in my people instead of the products, and focus more on...
Give me all the money.
So I learned a lot today, and I appreciate your help with this, Will. And if I guess I need to send my people to more conferences. They keep asking me, and I'm like, yeah, you're just going to party and drink, and it seems like that's part of the experience, but apparently there's a lot of good things to be learned at conferences and going to training, and this is the real thing that's going to help security, because I thought we had some pretty good security in place.
Yeah.
That's not a good place for that. Let me do that. And scene. So let's talk some mitigations. The initial foothold was pretty intense, right? There's a lot of different things that you can do to mitigate these sort of attacks. Not specifically this kind of OLE functionality within an email that comes to the user, but deploy Emmet, because that will help prevent and mitigate those memory attacks that can be used. App Blocker can block executable content from running in user locations like home directory, profile path. And often ransomware takes advantage of this. The user downloads something, and they execute it, and it runs. So you can use whitelisting. This is more like blacklisting. You block certain locations so they can't actually execute the content. You can manage PowerShell execution using AppLocker or constrained language mode. Matt next door probably has some ways around that. But again, these are all layers in your security. Just because one layer can be defeated doesn't mean you shouldn't put it in place. As engineers, we often want a 100% solution. You do not need a 100% solution. 40, 50, 60% is better than nothing. And it forces the attacker to change their methodology and makes it more expensive. So you want to enable logging like PowerShell and command process. Obviously, block Office macros where possible. Microsoft has backported functionality from 2016 to 2013, so any macros that come from the internet are automatically blocked and the user can't actually execute them. And then you want to deploy some sort of security tooling that looks for suspicious behavior. If a user has Word that's calling PowerShell or some other executable or doing something else that's wacky, it's probably bad. We can also limit this capability as far as executables that get onto the system. Executable type content, blocking email and download capability for certain types of files. You can also change the default program for scripting languages. JavaScript can actually be double-clicked on and executed by a user. We don't want that. Change that to Notepad, but please test first. Recon is a tough problem to solve. AD Recon, Active Directory is an LDAP directory, so that means you can pull pretty much everything from it at any given time. But there are ways to kind of limit this. If you increase the security on sensitive GPOs like security group policies, then the attacker doesn't have an advantage of just pulling everything that's in those group policies, opening them up, and knowing how your security tools like AppLocker and Emmet and others are configured, as well as what you have out there. And certainly evaluate some sort of behavior analytics tool like ATA. When we're talking about lateral movement, attackers moving from place to place within your environment, we want to make sure that the attacker isn't able to just run free. If they drop on a workstation, if you block workstation to workstation communication, or just allow specific ports, then they are constrained into a specific computer or environment, and it's very difficult to jump out of that. Look at LAPS, look at TrustedSec has ships, ways to change your local admin passwords that are out there. Do not try to roll your own. There are some good solutions out there that work very well. Privilege escalation. I still find some passwords in sysvol. Please make sure that you don't have passwords in sysvol. And when we're talking about Kerber roasting, the simple solution to this is make sure your service account passwords are at least 25 characters, preferably 30. Or use managed service accounts. Or get a password tool that will automatically change those passwords for you and make them super long and complex. The longer they are, the more difficult it is to be cracked. And if we make sure our computers are running NTLM v2 or Kerberos, it's a lot more difficult for passive credential theft like Responder to actually work. Which brings me to admin creds. If we make sure that all of our admins only log on to specific authorized admin systems, we can raise the bar and make it more difficult for those credentials to be stolen. If you add your admin accounts to protected users, which comes available in 2012, then they are not able to be delegated and they don't support insecure NTLM authentication. You also want to reduce the attack surface of your workstations and servers that are used for admin accounts. So control access, remove NetBIOS, probably doesn't need it. Get rid of LLM&R, get rid of WPAD. And this rolls over into legacy. Audit and restrict your NTLM authentication in your environment. If you don't know what's being used, there's no way that you can control it. Enforce LDAP signing. Use LDAP-S for any non-Microsoft Windows type applications. If it's Unixy, it's going to bind. If it's binding over LDAP, that's clear text. That is bad. Enable LDAP signing and encryption where possible. We want to disable these older protocols. I mean, who has seen WPAD used legitimately in an environment, right? A couple of times. But it's enabled everywhere, and Responder takes advantage of it, and pen testers and attackers can just drop on a system and ask for creds effectively. And in Windows 10, please uncheck SMB1 and PowerShell version 2. If you don't do this, certain tools like PS Attack can leverage the PowerShell version 2 and bypass all your fancy PowerShell version 5 logging. So in summary, once an attacker gets a foothold in your network, admin access is often quickly obtained. We showed a couple of examples. This is all fictional, but these are things that are being done in real life. And you want to make sure that you identify and model these offenses based on typical attacker activity. If you read about what's being done, look to see what the mitigations and defenses are, focusing on detection first, and then moving into mitigation and prevention. And then you can model those defenses. And then question how good your current defenses are. Do we have visibility into the right places? Are we seeing logs from our workstations? Can we see when some of these things that Will showed are actually happening in our environment? But if we measure our environment, like Carlos was talking about, measure the environment, document the environment, understand what you have, so that way you can figure out how to tighten it up and lock it down. Because ultimately, effective defense limits the attacker capability and their options and increases their cost. Thank you very much. So, because I was there. It was awesome, wasn't it? That was really hype. It was like one of the highlights of my trip so far. Is Method Man here? Oh, because I tweeted him last night.
Cool. Kick off. Go ahead.
So, good morning, DerbyCon. Yeah, that's a good response for having been up so late. This is Attacking EvilCorp, Anatomy of a Corporate Hack. I'm Sean.
And I'm Will. So just a little bit about us. Again, I'm Will Schroeder. My handle on Twitter is Harmjoy. I am a security researcher and pen tester red teamer for Various Group's Adaptive Threat Division. I've written a lot of code. I've developed in a lot of our tool sets. I'm kind of a co-founder and was one of the big developers on the Veil framework, PowerShell Empire, Python Empire. I wrote PowerUp, PowerView, helped with Bloodhound, which we're going to cover a bit during this presentation, along with a few other workmates that worked on that with me. I'm a Microsoft PowerShell MVP. Spoken at a few conferences. Spoke yesterday at DerbyCon. Had a great time, and I spoke a couple of years ago. So one of my favorite conferences for sure. But show of hands, who uses either Empire, Veil Framework, PowerView, or PowerUp on a regular basis? Oh, that makes me happy. So awesome. Lots of ponage.
So I'm Sean Metcalf, founder of Trimark, a security company. Microsoft Certified Master in Active Directory, one of about 100 in the world. Microsoft MVP, like my good friend Will here. Spoke at Black Hat, DEF CON, B-Sides, and DerbyCon. I'm really happy to be here at DerbyCon. Love DerbyCon. I'm a security consultant and researcher, and I own and operate 80security.org. Who's heard of or used 80security.org? Awesome. So, the setup for this is going to be a little different than your standard conference talk. We're going to put on a skit for the next 30 minutes. So we're actually going to shift from being Sean and Will, the nice guys that you like to hang out with, and I'm going to convert myself into the CIO of Ecorp, EvilCorp, right? And I'm going to talk about how perfect our security is. How we have great security. It's huge, right? And then Will's going to come up and he's going to go, no, it actually kind of sucks. And I'm going to show you why. So then after the skit, we're going to switch back to a standard slide presentation, and we're going to show you the mitigations that should have been in place or could have been in place to resolve those issues that we're about to show you. So this is where we switch.
Hello, DerbyCon. How are you today? I am the CIO of EvilCorp, the most secure network ever. We have a very large global Active Directory environment with lots of domains. We do lots of security with Active Directory to make sure everything is in good shape. We've got hundreds of domain controllers. We've got hundreds of thousands of endpoints, thousands of servers all over the world. We've got data centers to make sure that things are physically secure, and we have offices all over, and these are well connected, but we also have executives and other people that work from home and have mobile devices, so we have challenges with that. So we make sure we have really great security. And of course, we have a perimeter network for our customers and our suppliers, much like any other network, and we have our internal corporate network protected by firewalls. But not just any firewalls. These are next-gen firewalls. We have web content filters that filter out all of the bad code. In fact, it looks for the evil bit and it goes, no. We've got email security appliances that say, viruses, not today. We have VPN security using two-factor authentication, so there's no way that anyone who's not authorized, that I haven't signed a form for, can get on our network. We have endpoint security, antivirus, HIDs, HIPSIs. We've got all those things. Ultimately, EcorP security is the best, and we're unhackable. I'm sorry, there's a gentleman up here. You're saying that you don't think we're awesome, and okay, why don't you come up here? Let's see what you can do. What's your name, sir?
I'm Will.
Hey, Will, come on up. How you going? CIO EvilCorp. So here's my computer. Let's see what we're talking about here.
All right, so we're going to have kind of 5 different sections with this. So one of the first things you mentioned was kind of like categorization, web filtering, and kind of next-gen exfil.
Yeah, absolutely. We have web categorization with our web content filtering, and so that way users can't go to any bad sites.
Sure, so this is essentially a solved problem by the search engine optimization community. So we have a kind of a proof of concept tool that we'll be releasing later in the year after it's cleaned up called Imminent Domain. It'll search a number of different sites, like one of our favorites are domcop.com. So it'll look for domains that have just expired within the last couple of days that are already aged out and categorized. So beyond just the categorization issue, we see domain age is normally like a pretty big problem sometimes for getting exfil out. But in general, for the last year and a half or so, getting categorization in exfil hasn't been an issue for us. If you see down here, the imminent domain will actually search for wildcard type terms that are similar to whatever your target is. So your evilcorporation.com, we actually purchased that.
Wait a second. You purchased one of my domain names? Can you do that?
Sorry?
You purchased one of my domain names.
Oh, no, it's just a similar kind of snarf domain, but it was aged out, but it wasn't categorized, so this is a theoretical categorization page that we absolutely did not actually submit to. And this is actually a response email that totally doesn't have the site categorized for your evilcorporation.com. So, you know, this came in about 2 days ago. So normally the turnaround time is only about a day or so for these types of things. If you set up legitimate looking content, or if you want to be really sneaky, after you buy a domain that had just expired, go to archive.org, clone down the old content, and set it up on whatever the existing thing is. So it doesn't skip a beat. You know, you have the site went down for 1 day, it transferred owners, and then you just resubmit to whatever categorization you want, saying like, oh my gosh, what? I don't understand. I've been around for 10 years, so. Cool. So that's pretty much the categorization
So, hold on a second. You're saying that you can get around my web content filtering and the categorization that we do all the time by either buying a domain that's already categorized or setting one up and then just getting it categorized?
One of the next things you mentioned as far as next gen email filtering, you have OA, right?
Absolutely. That's great.
Do you have 2FA on OA externally?
Not yet, but it's in the works.
So it's one of our favorite things to hit, to where if we see any kind of external OA interface, if you guys aren't doing this, you absolutely should, is just do a site cloner, just do a cred stealer. Social engineering toolkit can do this. We tend to do it manually, so just having like really simple PHP snippet that will clone, save off whatever the creds are when people go through to the kind of spoofed login page, and then actually redirect to the legitimate login information. So really, really easy. Send the phishing email out. If you get through with a couple of people with the domain, you don't actually have to get your payloads by. You just have to get your creds, log into OA, and then re-spearfish internally. You can actually craft a lot of your messages much more kind of targeted, because you can read through the existing email correspondence. So you don't kind of hit that security uncanny valley to where maybe the signature is just a bit off, or if you address somebody a little bit differently and people kind of freak out.
So effectively, you purchase this domain, you got it categorized, one of my domains, I still don't understand, and then you send an email to one of my users or a bunch of my users and say, go to this OA page, and they go there and they log in, and then they don't get in, they get refreshed to our actual OA page, and then you steal their credentials. That doesn't seem right.
As far as payloads go, our kind of standard right now that we like to use are malicious shortcut LNK files embedded within OLAs in kind of Office documents. So shortcuts, you can create these maliciously pretty easily with a few. I've have to embarrass my friends. So it's a really cool project that applies graph theory to Active Directory attack paths. If you guys haven't checked it out,
so his name's Waldo?
Yeah, his name's Waldo.
Waldo's right there. I found him.
Yeah. So basically, we can take three pieces of information of who's logged in where, who has admin rights where, what users and groups belong to what groups, and that's it. We can collect all this information as an unprivileged user. We just need domain authentication, or we need a domain authenticated user, but we need no elevated privileges in the domain. With this, we can run a PowerShell ingester, which is essentially a customized version of PowerView that will enumerate all this information as fast as it can, and then spit it out either to a RESTful API interface or a bunch of CSVs that then we can ingest down. Then it's got a really, really nice dashboard for pathfinding and all this.
So I have a question about this. So you go through this email convoluted thing and somehow get code running on one of my workstations, which I don't quite get, but okay, fine. And then as a regular user, you can get all this information from the environment without any admin rights whatsoever, and then pull this into some sniffing tool named after a dog.
So from the pivot we're going to show, this user does not have local administrative access on the machine, and they're just in domain users. They have no elevated domain access. So for the two different attack paths we're going to show, kind of starting with recon, and then we'll move into the two paths, keep in mind that this is a completely unprivileged user. So I don't know how I'm going to try to narrate this. All right, because I can't actually see. All right.
I don't know.
Oh, man. Yes. Fool me once, Dave Kennedy.
Keep right there.
All right, see you, man. All right, okay, I'm going to try to click this video and then move right here so I can actually see what's going on. All right, so we're going to start up Empire. We have our fish user on, this is the really.evil.corp domain, and all the machine names and users are named after evil characters. So we fished Ramsey Bolton on the Searsay machine.
Ramsey, he's a good guy. I feel bad for him.
Okay, and we're going to run the Bloodhound ingester. So we're going to kick this off, and there's a couple different collection methods. By default, it's going to enumerate all the groups, all the group memberships and user memberships and everything, and it's also going to enumerate all the systems it can find on the domain, and then run enumeration threads to figure out the local administrators and session information for each. If that touches every single machine, it's kind of normal AD type traffic, but it's one workstation kind of spidering out and touching a lot of stuff. If you want to be a bit more stealthy, you can use the stealth collection, which will do just LDAP enumeration to a domain controller, then try to enumerate commonly trafficked servers by checking like home directory paths and stuff through user objects, and then it'll do the remote session and local admin enumeration against just those handfuls of commonly trafficked servers, and then it does some GPO correlation tricks for local admin. So stealth collection, not as accurate, but a lot faster and a lot quieter. So okay, we're gonna kick off the new Bloodhound module. It's an Empire 2.0 beta that was released yesterday. This is gonna send the ingester down, and it's going to be it's going to start kicking all the enumeration threads and everything off in the back end. And did the video start? Okay, yeah, cool. So you can see there, it did all the enumeration, it saved all the CSVs off. So now we are going to actually just download the CSV names, and then we're going to switch over to our Bloodhound analyst machine. So cool. Got all these pulled down. All right, so we're going to start up Bloodhound. It is cross-platform. It's written, the front end